Okay, so this is part two, and here are some common coefficient of kinetic friction for various substances. So it might be a good idea for you to write this down so that you have it on hand for reference for other problems. Now, here's some practice problems. These are some practice problems that we're going to be working on during class, so we'll just skip through these for now. It might be a good idea for you to write it down so I don't have to spend the time to actually go and do this in class. And there's number two, and this is a follow-up to number one. So again, write it down so that you have a reference for class so that we don't have to spend time doing this. And this is yet another problem. Again, write it down so that we don't have to spend time writing and copying this down in class. Alright, so let's talk about terminal velocity. Now the word terminal means the end, the very final velocity. And basically what happens is when we're falling down, an object is falling down, it will always experience air resistance. And because it experiences air resistance, it will have an upward force due to the air resistance. And whenever the object is falling and there's an upward force, at some point the upward force will be great enough to balance out the weight. And when that happens, we have an object that will reach a constant speed. And remember what we said about constant speed, where an object is at rest, that means the object is at equilibrium, which means the upward force is equal to the downward force of weight. So ultimately, this object would have reached the terminal velocity, where the final velocity of the object is dependent upon the shape or size. So that's how fast an object can go. So basically, when terminal velocity is reached, F net is equal to 0. So if you took a sheet of paper, two sheets of paper, one you crumple into a little ball, the other one you leave it as flat, and you drop the two objects, the two sheets of paper, the piece of paper that will hit the ground first will be the one that's balled up because of its shape and size. So the weight is the same, the mass is the same for both pieces of paper, but because of the shape and the size, you now have an object that will reach terminal velocity sooner due to it being very flat. So here's an object falling, and this is a skydiver. Alright, so this week we're going to be focused on two-dimensional forces on an incline. So last week we focused on one-dimensional forces and 1D, and it's basically going a straight line path horizontally. So now we're going to be on an incline. This now presents a different challenge altogether. We'll be spending a good deal of time focusing on how to draw a free body diagram and what does it mean and based upon its motion, where the forces are, things like that. Try to pay attention and take good notes so you can always make reference back to your notes whenever you need to. Okay, so basically the screencast will be focusing on how to draw, well, basically just not really how to draw, but where the forces are and such. In class, what we're going to be doing is we're going to be drawing and practicing the free body diagram and then focusing on the problem solving aspect of it. So in this particular example, there's this box on an incline. Okay, so here's the box, and this is the incline. So now we will have to set the coordinate system. So how would you do it? So where would the x-axis be and where the y-axis be? The reason I asked that question should be a hint. So if you look at it, the x-axis is the horizontal aspect of the problem, but now there isn't a horizontal aspect, there's only a vertical. And it's on an incline, so it's kind of all weird. So what would you do? If you had looked at the PowerPoint already, you would know that you will tilt the axis so that the axis is now horizontal, well, not horizontal, but parallel to the inclined plane. So you see how if this angle was 10 degrees right over here, if this angle was 10 degrees, so this is now the surface. Okay, that's the surface. And so if you were to take your x-axis and tilt it so that the line, the imaginary line over here that's parallel to this incline is now the x-axis. The y-axis will be perpendicular to the surface. Remember, when we say perpendicular to a surface, that's a special name for a force called a normal force. So these two questions, go ahead and try to figure that out and see if you're able to discern what that means. It takes a little bit of looking and reading into the question for you to answer it, but go ahead and try to answer that. So if the angle of the incline is 10 degrees, what is the angle between the horizontal and the y-axis? Okay, and the answer would be, well, we'll do that in class. Be sure somebody to ask it. Second question, if the angle of the incline is 10 degrees, what is the angle between the vertical and the y-axis? So go ahead and try to answer that. So we'll draw it in class and see if you're able to figure that part out. So now we've got to figure out the forces that are acting on the box. Again, we'll be drawing free body diagrams for friction forces on an incline so that you'll be better prepared for this week's quiz. So then now, how does the incline affect the value of mu k? Go back to the question, what determines mu k? So go and figure that part out and see if you can answer this question. We'll answer these questions in class. So the strategies for solving the problems remain the same except when drawing a free body diagram. So in other words, you will take your x-axis and your y-axis and you tilt it so that the x-axis is parallel to the surface of the incline. And so by doing so, you will still have x and y, which are still going to be at 90 degrees to each other, and therefore we can still use what we have learned about free body diagrams and solving the friction problems in exactly the same way. So the free body diagram is the only thing that changes, and a few of the forces will be tweaked. So here's a practice problem. Go ahead and copy this down. We'll be working on it in class. If not Tuesday, then possibly Wednesday. Okay. And here's another problem. And this time the incline is 25 degrees. We've got a mass of the box, 55 kilograms. Again, we'll be working on it in class. Try to copy this down so we have some basis of working on it. And yet another question. So go ahead and pause, write a question down so you have a better understanding of what this whole thing is trying to ask you when we get to it in class. So in the class we'll be doing a lot of practice problems, and remember that Wednesday, Thursday you should have the worksheet printed out so that you can use the worksheet to practice more of these problems. And that basically concludes part 2. It was rather short, less on concepts but more on problem solving the incline friction problems. So as of right now, go ahead and review over the different types of problems. Remember to ask a bunch of questions, and do not forget about doing the web assignments this week. It will be posted tomorrow so that you will have access to it tomorrow evening, which is basically Monday night evening. Okay, that would be it.